In this question we have a block which is resting on a table, and the block has a 3 kilogram weight, so it's a 30 Newton mass, and it's on the table and it's hooked up with a piece of string and a pulley and another mass which is 0.3 kilogram mass, which is a 3 Newton force down. Now this distance is 0.8 meters, this distance is 0.9 meters. Now the thing is about this string is that it's light elastic string, so it has a modulus of elasticity of 70 newtons, and it has a natural length of 1.4 meters. So let's have a look at the stretch right now. So we've got 0.9 plus 0.8. Now that is 1.7. Therefore the stretch is 1.7 minus 1.4. The stretch is 0.3 meters. Now the question is stating that the particle is released. The particle is released from the level of the pulley, and it's released, and it drops. And by the time it's at this point P, at that moment, then this block B is at the point of equilibrium, and so it is just about to move. Now let's have a look at the tension in the string. We want two things. We want the velocity at P, and we want the coefficient of the friction between the block B and the table. Okay, so let's have a look at the energy level first. Sorry, the energy level. So I'll just change color here to, alright. Now at the top we've got mgh, elastic potential energy, we've got kinetic energy, and we've got elastic potential energy. Let's have a look at the sum of those three, and then at this level we've got potential energy, kinetic energy, and elastic potential energy. But when it's dropped, it's mgh, we've got a height of 0.8, so we've got a mass of 0.3, gravity 10, and it's 9.8, but we're going to use 10, and h of 0.8. So that is 2.4 joules. Its kinetic energy, because it's released, is 0. Its elastic potential energy, because there's no stretch in the string, is also 0. Therefore, a sum total is 2.4 joules. Let's have a look at the mgh at the bottom of the full, which is 0, because 0.3 times 10 times 0 joules. Its kinetic energy we don't know, so it's half times mass 0.3 times v squared. That's going to help us find the velocity at v. Its elastic potential energy is, now here's the formula, so we've got 70 divided by 2 times 1.4, I'll just say 2.8, and the stretch is 0.3, so 0.3 squared. So 70 divided by 2.8 times 0.3 squared is 2.25 joules. Right, so therefore we have, if we are going to have a sum of 2.4 joules, the kinetic energy will be 0.15. Therefore, working with this formula, if we take 0.15, multiply it by 2, divide by 0.3, so divide by 0.15, we get 1. Therefore, we have a velocity of 1 meter per second. And so that's the velocity 1 meters per second. The coefficient of friction, well, we've got a normal on the force of 30 newtons, and the tension in the string is 70 over 1.4 times 0.3. So we've got a 15 newton tension in the string. Therefore our friction coefficient times normal, so 15 equals our coefficient times our normal, which is 30. Therefore our coefficient of friction is 0.15. I hope this has helped. Until I help you again, stay happy.